Great. Thanks a lot for having us on the program. So this paper is joint with Hanno, who's sitting right over here. The starting point for this paper are some classic puzzles in international finance. In particular, if you take macroeconomic quantities, call it trade, consumption, output, basically anything, and you try to forecast changes in exchange rates using these differences in macroeconomic quantities across countries, what you find is that you can't do very well. More specifically, it's really hard to beat the random walk in terms of forecasting exchange rates. But the puzzle turns out to be worse than you could actually even imagine. If you look at contemporaneous covariation of macroeconomic quantities with changes in exchange rates, you see that it also doesn't work out very well. The first of these puzzles is the classic Misi-Rogoff puzzle, and the next is related to work by Fruit and Rogoff or Frankel and Rose. That's known as the exchange rate disconnect puzzle. Well, in this paper, we're going to take a different perspective on exchange rates and show that if you look at exchange rates in a different way, their behavior turns out not to be as disconnected from very fundamental things about countries as you would think. So one thing that we've learned in recent years is that exchange rates tend to covary. For example, when the US dollar appreciates systematically against a basket of currencies, it does so in relatively stable proportions over time. So let me be more specific about that. Say we take bilateral exchange rates with respect to the US dollar. S here is the exchange rate in foreign currency per US dollar. An increase in S implies an appreciation of the dollar. What we do is we construct a US dollar base factor. What it is just the average appreciation of the dollar versus some basket of currencies. You could think about this similar to a market factor when we look at equities. And we take this US dollar base factor, the average appreciation of the dollar, and you can regress bilateral exchange rates with respect to the dollar on this US dollar base factor. So call this the Australian dollar US dollar exchange rate, regress it on the average appreciation of the US dollar, and get a base factor loading. We're referring to those here as phi. Now, what do these base factor loadings tell you? They tell you when the US dollar systematically appreciates by 1% against some currency, they do so by whatever this base factor loading is versus that foreign currency. You can think of this similar to a market beta for equities. Now, it turns out that exposure to these base factors explains a substantial amount of the time series variation in bilateral exchange rates. And additionally, these loadings on these base factors have a relatively stable component over time. And so the question which this paper answers is what determines the cross-sectional variation in these loadings across countries? When the dollar appreciates systematically, which countries does it appreciate more against, and which countries does it appreciate less against? And our answer to that is going to be something very fundamental about countries. It's going to be measures of distance between these countries. So not only just physical distance, but things like economic and cultural distance, sharing a common language, sharing common colonial origins, all of these classic gravity variables from the trade literature. And so what we find is that when a currency systematically appreciates against a basket of currencies, it does more so against currencies of countries that are farther away. Countries that are closer away tend to covary more with this base factor, or with the base currency. And so before I jump into the empirical results, what I want to do is show you why it's interesting to study these loadings phi on the base factors. In particular, these base factor loadings measure exposure to global factors. And I'm going to show you this in a fairly standard linear stochastic discount factor model. Now, as a result of these base factor loadings measuring exposure to global risk factors, these base factor loadings turn out to be a significant determinant of currency risk premia in any model. And now I want to take one more interpretation of these base factor loadings. Suppose that you're a US dollar-based investor and you're taking a long position in some foreign currency. Well, these base factor loadings tell you the incremental amount of systematic risk that you're taking on in a long position in that foreign currency. You can think about the US dollar base factor as a systematic move in the US dollar. Currencies that are more exposed to that systematic move are going to be more exposed to the systematic risk of US dollar moves for those US dollar-based investors. And that also gives us another interpretation from these regressions. The R squared in this regression is just a measure of the systematic risk as a fraction of the overall variation in whatever bilateral exchange rate is on the left-hand side. Okay, So to motivate why we're using these base factors and why we think it's interesting to study these base factors, I'm going to write down a very simple no-arbitrage linear factor model here. In this model, there's going to be n+1 countries. One of these countries is going to be special. It's going to be the home country. Every foreign country is going to have an asterisk on its quantities. Now, this linear factor model nests all kinds of models of exchange rate determination that you could imagine. Long-run risks models, disaster models. At the end of the talk, I'll come back to a long-run risk model that's nested within this framework. Now, each of the countries has some log stochastic discount factor. The foreign country's stochastic discount factor has two shocks in it. The first is a local shock, ut+1, and it's specific to each of the countries, the home country, and then each foreign country is going to have a local shock. There's also a common shock, ut+1g, which, to give content to these shocks, I'm going to assume that the shock originates in the home country. The foreign countries are all going to have heterogeneous exposure to this shock, and the exposures are all going to be measured by this variable kappa star here. To give content to the notion that the shock originates in the home country, we're going to assume that the home country's loading on this shock to its marginal utility growth is equal to 1. Another assumption that we're going to make is that the loadings on the common shock, kappa star, decrease in the distance between the home country and some foreign country's star. That is, the farther away a country is from the home country, the less exposed that country is to the shocks that drive the marginal utility growth of the home country as well as the foreign country. Now, exchange rates in this model are simple. We're going to assume that there's complete financial markets. You can trade complete state contingent claims across international borders. And so complete markets gives us that changes in exchange rates, where the exchange rate here is in foreign currency per unit of home currency, call it the US. Changes in exchange rates are just the difference in the stochastic discount factors between the home country and the foreign country. When the home country has a relatively high marginal utility growth relative to the foreign country, that home country's exchange rate ends up appreciating here. This is a direct result of no arbitrage in complete markets in international markets. Okay, so now we've got exchange rates. We can calculate our base factors. For all of the set of foreign currencies, all we do is just calculate the average appreciation of the home currency versus some basket of foreign currencies. That's what we're doing here. Now, why would we do that? When we calculate the base factor, you can see the foreign country local shocks are all going to drop out. All of these shocks are IID across countries. And so the base factor, you're left with just the home country's local shock. And then this here, this kappa star bar, is the average loading of foreign countries on the common shock. And the 1 is the loading of the home country on that shock. Right? So the base factors average away all of the local shocks that originate in any of the local countries. And we're left with just the difference between the average exposure of a foreign country on the shock and the exposure of the home country on that shock. Now, the interesting quantity to look at here is, for example, the variance of the base factor. What you can see is that the variance of the base factor is increasing as the foreign countries have a more different loading on the common shock than the US. The US has a loading of 1, and if the foreign countries load very differently on that common shock than the US does on average, then the variance of the base factor is going to be higher. And we can also calculate the base factor loadings here. That is just the projection of the change in some foreign exchange rate on the average appreciation of the US dollar. What you see here is that the base factor loadings are decreasing in the foreign country's exposure to the common shock. The US has a loading of 1 on the shock, and as the foreign countries have a loading that is decreasing from 1 towards 0, you can see that the base factor loadings are increasing as the country has a lower and lower loading on that common shock. So let's take 2 examples. The first will be the lower bound for these base factor loadings phi. The lower bound happens when the foreign country has exactly the same loading as the US or the home country. Right? When the US dollar appreciates against a basket of currencies systematically, It does less so against currencies of countries that have the same loading on the common shock. Take the other case. Suppose that the foreign country is not at all exposed to the common shock which drives marginal utility growth in the home country. That's going to be the upper bound for the base factor loadings. When the base country, or the home country, appreciates systematically, it does more so against currencies of countries that are not exposed to that common shock. Right? And so, in general, a high exposure to the common shock that drives marginal utility growth across countries means a lower base factor loading here. Critically, and what I want to highlight here is these base factor loadings are not related to any of the idiosyncratic shocks that originate in the home country or the foreign country. And that's why these are interesting to study. This is about common global shocks that drive marginal utility growth across countries. Whereas something like bilateral exchange rate volatility is going to be contaminated by both idiosyncratic shocks that originate in the home country and idiosyncratic shocks that originate in any of the foreign countries. Additionally, these base factor loadings phi determine currency risk premium. This is the currency risk premium for a home country investor taking a long position in the foreign currency. As the foreign currency has a higher base factor loading, that is more exposed to the systematic risk, the currency risk premium is going to be higher for a home country investor taking a long position in that foreign country. Okay, that's given us all the reasons why we should study base factor loadings. They're about exposure to common global shocks. Now I want to turn to the empirical section of the paper and show you how we're actually going to measure these base factor loadings and what we're going to do to explain the cross-sectional variation in these base factor loadings. So all the way through now, I've been talking about just taking US dollar-based exchange rates, calculating a US dollar base factor, and looking at bilateral exchange rates with respect to the US dollar's exposure to the US dollar base factor. Well, there's no reason that we have to do this just with the US dollar base factor. We could take exchange rates with respect to the British pound, construct the average appreciation of the British pound versus some basket of currencies, and look at how pound-based exchange rates covary with this pound factor. And that's what we're going to do here. We're going to get each bilateral exchange rate with respect to some base currency I and get its exposure to that base currency's base factor. That's going to give us a set of base factor loadings, phi ij, for all base currencies and for all foreign currencies with respect to each of those base currencies. Now, why would we do that? This actually will uncover additional information about exposures to global factors as long as there is more than one global factor which drives marginal utility growth across countries. If there's only one global factor, then there's no reason to undertake this exercise. If there's one global factor, you can look at exposures with respect to the US dollar base factor and uncover all of the information. If there's more than one global factor, which from prior literature we know is more than one global factor, for example, the US dollar factor, the carry factor, or you could potentially have other global factors or other regional factors, what we uncover is additional information. Why is that? These base factors are just simply linear combinations of the underlying factors which drive exchange rates with respect to some base currency. The only thing that we have to be careful about is that the base factor loadings might be correlated with each other if the same country is the base country, the foreign country, or vice versa. And so what we're going to do when we run explanatory regressions of base factor loadings on measures of distance between countries is control for dyadically clustered standard errors. In particular, if the same country is the home or foreign country, then we can have arbitrary correlation. If it's a different country, then we're going to assume that it's zero. And this controls for the cross-sectional correlation of these base factor loadings in our second stage regression of base factor loadings on distance. And so what do we find? As I mentioned, we find that the base factor loadings are increasing in measures of distance between countries. When a currency systematically appreciates against a basket of currencies, it does more so against currencies of countries that are farther away. That is, the base factor loadings are just proportional to distance. This echoes findings from the trade literature, where we find that logs of trade volumes are inversely proportional to measures of distance. And so here's the data. Our primary sample is going to come from global financial data. It's going to be for 24 developed and 23 emerging countries as classified by MSCI. Nominal spot rates are going to be monthly. We'll start in January 1973, and we'll go through December 2014. When we run regressions of changes in exchange rates on the base factor, we're going to omit the foreign country itself when we construct the base factor so that there's no possibility of a mechanical relation in the change in the exchange rate on the base factor. We'll take real spot exchange rates by subtracting off inflation differences, and then we're going to have some gravity variables, which I'll talk about on the next slide. Here's the summary statistics of our sample. The average loading of some foreign currency on the base factor is almost exactly 1. The only reason that it's not exactly equal to 1 is because we're omitting the foreign currency when we construct the base factor itself here. Otherwise, that average loading would be equal to 1. The other thing I want to highlight on this slide is that the average R squared in these regressions of exchange rate changes on the base factors is 47%. That's quite high. Exposure to the base factors explains almost 50% of the time series variation in these exchange rates. And here's our gravity variables. We've got a measure of physical distance between the large cities and countries. That's going to be our log distance. We've got a dummy variable for whether the populations share a common language. About 13% of the populations do. We've got a dummy variable for shared border. Additionally, we've got something new, which is natural resource similarity. What we do here is we go to the CIA World Factbook, get the list of natural resource endowments, construct a vector for each of these countries, and look at the cosine distance between these vectors of natural resource endowments for the countries. We've got a continuous measure of linguistic proximity and of genetic distance. We've got a dummy variable for common colonial linkage, and we've also got a variable for whether the nominal exchange rate between countries is pegged to each other. I'll come back to that. So here's our main results. We're going to take all of our base factor loadings for all of the pairs of countries. We're going to regress them on bilateral measures of distance between countries. What do you see here? In the first column, we're just using physical distance between these countries. What you see is that the further away a country is from the base country, the more exposed it is to the systematic variation in that base country's exchange rate. Surprisingly to us, we explain almost 20% of the variation in these loadings just with this measure of physical distance. Turning to the second column, we're going to include some more controls here. What do you see? If countries share a border, this lowers the loadings. Right? You can think about these dummy variables for sharing a border or sharing a language as being kind of the inverse of distance. So if you share a language or you share a border, you're closer, that's going to lower the loadings. In this fourth column, what we're doing is controlling for pegs of the nominal exchange rate. Potentially, countries will peg their nominal exchange rate to countries that are closer together. Take the case of Hong Kong pegging to the US. They're not necessarily close, but Hong Kong pegs its exchange rate to the US dollar. What does that mean the base factor loading would be for Hong Kong on the US dollar? It would be 0 if the peg is perfect. When the US dollar appreciates systematically against a basket of currencies, it doesn't at all versus the Hong Kong dollar. Right? So if countries peg their exchange rates to countries that are closer, that could potentially be lowering our base factor loadings here. So we need to carefully control for pegs. You can see that when we control for pegs here, we do lower the base factor loadings. But we can omit the pegs altogether, and we still explain about 10% of all of the variation in this. Now this is a full sample. What we're doing here is we're taking the base factor loadings for all 40 years, right? Just one single estimate in the time series. And indeed, what we do find here is that countries are likely to peg their exchange rate to countries that are closer. Here's those results. These are marginal effects from a logit model, where we put the peg dummy on the left-hand side and just regress it on measures of distance. What do you see? If countries are further apart, they're less likely to peg their exchange rate. So we can turn to a rolling sample and better control for the pegs. And in particular, we'll run a 60-month rolling sample where we estimate the base factor loadings using a 5-year rolling window. This will allow us to better control for the pegs because bilateral exchange rates aren't pegged to each other the entire sample. Bilateral exchange rates are defined as pegged if the bilateral volatility in 2 consecutive years is less than 2%. This comes from Jay Shambaugh. And so here's the results for the rolling sample. We're going to run the regressions, but in these regressions, we're going to include a time-fixed effect. The results are very similar, right? We explain 10 to 20% of the variation in these loadings. Notice that the peg dummy comes in more significant here. The peg dummy in the full sample regressions was minus 0.23. Here it's minus 0.5. We're better targeting the pegs using the rolling sample. Again, if you omit the pegs, our results carry through. Base factor loadings are increasing in distance between countries. This effect turns out to be stronger within the sample of just developed countries. So before we were looking at developed and emerging, if you just look at 23 developed countries, you see that the R-squareds in these regressions turn out to increase. In our main sample here in column 3, we've got a 33% R-squared in terms of explaining the cross-sectional variation in these base factor loadings. We think that's remarkably high. A natural question that comes up is whether bilateral trade intensity or some functional form of trade is just the right summary statistic for all of these gravity variables on the right-hand side of these regressions. So what we do is we control for bilateral trade. Trade comes in with the right coefficient. If countries trade more, it lowers the base factor loadings. But trade only explains about 3% of the cross-sectional variation in these loadings. There's something else going on beyond trade that relates these gravity variables to exposure of currencies to systematic currency variation. Another question might be, do bilateral asset holdings drive out gravity? Here we're going to use bilateral asset holdings from the IMF's Coordinated Portfolio Investment Survey. These results echo exactly what you see with the trade data. Bilateral asset holdings don't explain a lot of the variation in this. All of the gravity variables remain significant when we control for bilateral asset holdings. Another question is, what does this look like in the time series? How much of the cross-sectional variation over time are we expanding in these base factor loadings? Here we're taking our R-squareds from estimating the base factor loadings using the 5-year rolling window and just looking at those 5-year estimates of the base factor loadings on measures of distance over time. What you see, this is for the developed sample, is that prior to the financial crisis, this was remarkably stable, about 40%. When you hit the financial crisis, this drops down to about 15% and has been slowly creeping back up towards 40% after the financial crisis. All right, now I want to turn this problem on its head. Recall that we could think about this regression of bilateral exchange rates with respect to the US dollar on the US dollar base factor as a measure of the amount of systematic risk that a US dollar investor takes when they take a long position in this foreign currency. Right, we can just look at the R-squared in that original regression, and this tells us how much systematic risk that foreign exchange rate has. Well, for a US-based investor, we could just look at the entire basket of exchange rates and average over this R-squared. See the average amount of systematic risk that a US dollar investor faces on their basket of foreign currencies. Right? This will just be the average of the R-squared for some base currency across all of these regressions. What do you see? This is the average R-squared for each base currency. You see on the left some countries that are, on average, quite distant from other countries, whereas countries on the right tend to be quite a bit closer to countries. Now, we've got, for example, Singapore, US, some European countries, whereas on the left, we've got New Zealand, Australia. Now, that's just some intuition. What am I going to do here? I'm going to regress this average R-squared, the average amount of systematic variation that a base country investor faces in their basket of exchange rates on measures of average distance. So for example, take the average distance of the US from every other country globally and look at how much of the variation in this average R-squared we explain. Well, it turns out that countries that are on average distant from other countries have bilateral exchange rates that are more exposed to systematic variation. Right? As you're further and further away from countries, your bilateral exchange rates have more systematic variation. We can do that with just distance, but we could also take the average of the first principal, or the principal component of these gravity variables. We find a similar effect. The last thing that we can do is take a measure of a country's position in the global trade network, the lead eigenvector of a matrix of bilateral trade intensities. This just measures your position for global trade. Turns out that countries that are very central in the global trade network don't have very much systematic variation in their bilateral exchange rates. And countries that are very peripheral have a lot of variation in their bilateral exchange rates, at least a lot of systematic variation. What I want to do for the last few minutes is show what sort of implications our findings here have for models of exchange rate determination. So I'm going to write down a long-run risk model so that we can get the quantitative side of the model right, but you could do a similar exercise with a disaster model or something similar. There's again going to be n countries. Foreign countries are denoted by asterisks. Each country has a representative agent that has recursive utility, so they care about consumption growth today and the future return on the wealth portfolio. The consumption processes in each country are going to have two components. They're going to have an idiosyncratic component, and then they're going to have persistent components, XTNA and XTE. These persistent components are going to be common globally, but countries are going to have differential exposure to these persistent components. I'll just label them NA and Europe, so North America and Europe for simplicity here. The base country, or the home country, is going to have a loading kappa NA on this first persistent component, and a loading kappa E on the second persistent component of consumption growth. The foreign countries are similarly going to have loadings on these persistent of consumption, or the persistent components of consumption growth, but they're going to be different loadings. There's going to be heterogeneity and exposure to these global shocks to consumption growth. So we just go through the same exercise that we had at the beginning. We use complete markets exchange rates, which are just differences in the marginal utility growth across countries. And these are related to differences in exposure between the home country and the foreign country. Now we can get rid of the idiosyncratic shocks to the foreign country by averaging over all of these bilateral exchange rates and calculating our base factor. The base factor, particularly the variance of the base factor, is just related to the difference between the home country's loading on that persistent component of consumption growth and the average of all of the foreign countries' loadings on that consumption growth. As the foreign countries have different loadings, more and more different than the home country, on those common components, the variance of the base factor is going to increase. We have a similar result for the base factor loadings themselves. Right? We can project bilateral exchange rates on the base factor loadings, or on the base factors, and we can see that the base factor loadings are decreasing in the difference between the home country's loading and the foreign country's loading on these common shocks. That is, when a currency systematically appreciates against a basket of currencies, it does more so against currencies of countries that load on different common global shocks, or load differently on these common global shocks. And so what we can do is we can calibrate this model. We calibrate this model just using kind of standard results from the literature, Colatrito and Croce's parameters. And what we can find is what we're going to do is take our base factor loadings. These are just reduced form base factor loadings from the data, say with respect to the US dollar and with respect to the British pound. You see how much the pound appreciates systematically versus pound-based exchange rates, and how much the dollar appreciates systematically against dollar-based exchange rates. And these base factor loadings have strong implications for the underlying exposures that are implied for consumption growth in this long-run risk model. So on the left side here, we have the implied exposures to these common global persistent shocks to consumption growth. We're doing this in the two-factor model. So on the x-axis here, we've got the exposures to factor 1, y to factor 2. One was North America, one was Europe. That was just for labeling. But what you see here is that European countries tend to have very similar loadings to each other on these common global factors, whereas those are very different than the implied loadings of, say, the US and other North American countries. And so the takeaway from this is that our exposures to these base factors imply a substantial amount of heterogeneity in countries' exposure to common global shocks in any model of exchange rate determination. And this is indeed the case if you take the correct weighted average of these implied exposures in this long-run risk model and regress them on measures of distance. You see that those measures of distance explain a substantial amount of the implied exposure in these common factor exposures. And so what do we have? I've shown you that the systematic risk of a long position in foreign currency depends on how far your country is from some base country. This is not explained entirely by trade or bilateral asset holdings. And so we have a gravity model of systematic risk in foreign exchange. The amount of systematic risk in a bilateral exchange rate ends up being proportional to the distance between the home country and the foreign country. Also, peripheral countries, countries which are on average distant from other countries, have bilateral exchange rates which are on average more exposed to systematic risk. And finally, models with endogenous exposure, or just any exposure to common global shocks, should match this multi-country distance-based factor structure in exchange rates. That's all.